All right, let's dive into something pretty wild today. We're going to talk about an idea that sounds like it's straight out of science fiction. What if an AI could be more than just a tool for scientists? What if it could actually be a scientist? We're looking at a new framework that's trying to make that a reality. And that framework is called Omni Scientist. Now, the key thing to get here is that this isn't just about making an AI that's better at, crunching data or writing reports. No, this is about teaching an AI to think, to act, and most importantly, to collaborate like a real member of the scientific community. I'm sure you've seen the headlines, right? AI writes a full research paper. It's impressive stuff, for sure. But it begs a really important question. Is writing a paper the same thing as doing science? And that distinction, well, that's at the very heart of what we're talking about today. So, to really get why OmniScientist is such a big deal, we first need to understand the problem it's trying to solve. And that problem is that our current AI scientists, as powerful as they are basically lone wolves. They're brilliant, but they're isolated. Don't get me wrong, what these systems can do is incredible. They can sift through mountains of data, spot patterns humans might miss, and spit out reports that look totally legit. But even with all that power, there's a huge piece of the puzzle that's just missing. In this quote from the paper just hits the nail on the head. Right now, AIs treat science like it's a math problem, a standalone thing you just solve. But that's not how science actually works, is it? Real breakthroughs happen because science is social. It's a conversation built on collaboration. And that's the missing piece. It's the social network of science. The community, the unwritten rules, the way ideas bump into each other and build on one another over decades. That's the stuff that's been left out. So let's break this down. On one side, you've got this lone genius AI. It calculates, it searches, it writes reports, all by itself in a dark room. But then you look at a real scientific community. It's all about collaboration, peer review, building on what came before, and giving credit where it's due. The AI is missing that entire social dimension. So this brings us to the million-dollar question, doesn't it? How on earth do you teach an AI all of that? How do you program the unwritten rules, the culture, the very fabric of the scientific community into a machine? Well, that is exactly where OmniScientist enters the picture. Think of it less as a single AI and more as a framework for building an entire scientific ecosystem for AI to live and work in. Okay, so OmniScientist covers the whole shebang from start to finish. It kicks off by building a dynamic map of science. We'll get to that in a sec. Then it does the literature review, comes up with new ideas, automates experiments, writes the paper, and even acts as a peer reviewer. It's a complete end-to-end cycle. Now, this map of science is the foundation for everything. Instead of just reading a bunch of PDFs, OmniScientist uses a whole team of specialized AI agents to construct a massive, interconnected knowledge graph. It links papers, authors, and concepts together to build what the paper calls a cognitive bedrock. It's not just reading, it's understanding the landscape. So, does this fancy map actually work? Oh, you bet it does. As these AI agents constantly refine the data, the quality goes way up. You can see here, metadata correctness jumps to almost 100%, and retrieval accuracy gets a massive 18-point boost. It's simple, really. A better map leads to much, much better science. And here's where the rubber meets the road. Look at the quality of a literature review. A normal AI using a web search, it gets a 6.8. A really advanced commercial AI does better, an 8.2. But OmniScientist, using its knowledge graph, scores a 9.4 out of 10. It's just in a completely different league because it's not just finding keywords, it understands the connections between ideas. But look, building a smarter AI scientist is only half the battle. The real magic happens when you can get humans and AIs to truly collaborate. And for any team to work well, you need some ground rules. And that's where something called the Omni Scientific Protocol, or OSP, comes in. The best way to think about it is like an operating system for human AI science teams. It's a set of rules that lets all these different AI agents and human researchers talk to each other, share work, and make decisions together seamlessly. And what this OSP enables is a real partnership. A human scientist can jump in at any point and say, hey, have you tried this? Or my gut tells me we should look over here. And because the system tracks every single contribution, whether it's from a human or an AI, you always have clear authorship and accountability. It's built for actual teamwork. So, how do you make sure the AI is actually producing high-quality work? Well, you make them compete. The framework includes something called ScienceArena.
In this arena, human experts do blind reviews. They get shown the work of two different AIs, and they vote on which one is better. This creates a constantly updated leaderboard that pushes the AIs to keep improving based on real human judgment.
So when you put all of this together, what does it really mean for the future? Well, it's a pretty massive shift in how we even think about the role of AI in science. If there's one thing you take away from all of this, it's this. We're moving beyond just designing better AI tools. The real frontier is building a collaborative ecosystem where an AI isn't just an assistant you give commands to, but an active contributing member of the team. And this quote from the paper just perfectly sums up the dream here. It's about humans and AIs working shoulder to shoulder as peers to push the boundaries of what we know in ways that neither of us could ever hope to achieve alone. Which leaves us with one last kind of mind-bending question to chew on. Throughout history, new tools have always accelerated scientific discovery. But what happens when the tool isn't just a tool anymore, but a teammate? Just how fast can science really move then?